This graphic representation shows Lake Biwa as an empty container. This kind of picture seems to provide a very helpful image of the lake. By the way, how does that shape reflect the actual geometry?
The representation shows a distorted view, placing more emphasis on the depth of the lake than on its length. As you can see, the north-south length of Lake Biwa is about 60 kilometers. The deepest part of the lake is about 100 meters deep. It is 1/600th of the width. Therefore, if we had actually reproduced the exact geometric shape, it would be as thin as this paper.
It is very hard for me to conceive that Lake Biwa is as thin as a sheet of paper. Lake Biwa is a kind of reservoir collecting the water from hundreds of rivers. Lake is a part of a watershed that has only one natural outflow, the Seta River. Would you show us the gross water balance of the lake?
The volume of Lake Biwa is about 27.5 times 10 to the 9th cubic meters. The rivers bring about 4.5 times 10 to the 9th cubic meters into the lake per year. Additional rainfall adds 1.3 times 10 to the 9th cubic meters of water per year. Therefore, a total of 5.8 times 10 to the 9th cubic meters is supplied.
Does the 5.8 times 10 to the 9th cubic meters represent the total outflow of waters from Lake Biwa into the Seta River?
No. There is also 0.6 times 10 to the 9th cubic meters of evaporation of water. Therefore, the annual total outflow of the lake is about 5.2 times 10 to the 9th cubic meters.
And so as this panel shows the total volume of the lake 27.5, which is divided by 5.2, the total annual outflow per year. That means it takes 5 years for the water that is lost to be replaced. But I once heard the renewal time is 10 or 20 years and not 5 years. Which one is more correct?
We cannot figure out the renewal time by such a simple calculation. We have to consider the mixing of water in the lake, because some of the water stagnates.
Is there any relationship between the water flow and the quality of the water in the lake?
Water quality strongly depends on the internal mixing of the water. There are circular currents covering the surface of the lake, which we call gyres. They are almost horizontal and mix the lake water. It looks like what happens when we stir milk in coffee with a spoon.
Is that so? Would you explain more precisely about the gyre?
Mr. Kumagai is going to illustrate.
It is said that there are 3 big gyres in the northern basin of Lake Biwa. Please look at this panel. This is the result of the observation in 1925 by Kobe Marine Observatory. The first gyre from the north swirls counterclockwise. The second one swirls clockwise, and the third one moves counterclockwise. We can say that the water in the northern basin of the Lake Biwa runs from north to south, forming the gyres.
How do you study that kind of current? Is it possible to see it from an airplane or from an artificial satellite?
Unfortunately, we cannot see the gyre from a plane or an artificial satellite. Some researchers observe the size and the position of the gyres by taking photos of muddy streams of rivers at flood. Many use the direct observation method when studying Lake Biwa. For example, Kobe Marine Observatory uses cross-buoy drafts to measure the surface stream pattern. Shiga University uses a rotary type of current meter to measure the speed of the lake stream directly underwater. In Lake Biwa Research Institute, we try to use a supersonic current meter. But we have some problems with this type of observation. First of all, Lake Biwa is too large to measure in a wide area at one time. Secondly, the weather changes so suddenly that it is quite difficult to observe over the long term. Finally, the expense is great. We must pay for measurement instruments, boats, and so forth.
Now I have understood the difficulty in measuring the currents. By the way, do the currents keep flowing throughout the year?
No, they don't. They are formed from spring to autumn and disappear from autumn to winter every year. This phenomenon is related closely to the distribution of water temperature. Dr. Onish, please explain this point.
Here, we have a panel showing the distribution of water temperature. At the surface, the temperature varies seasonally. But at the bottom, the temperature is almost constant and relatively cool. As is shown here in the summer, the warm and light water is floating on the cold and heavy bottom water. It is this warm water that circulates horizontally in the lake.
What is the major cause of the lake currents? I once heard that it relates to the Earth rotation.
Yes, it does to a certain extent. The Earth's rotation doesn't generate the current. We need either heat or wind to initiate the current. In our academic circle, the influence of heat and or wind are represented as heat generating theory versus wind generating theory. Once a current is generated, then the Earth's rotation helps develop the current.
That's why you are using a hydraulic experimental model in order to clarify the mechanism of the lake currents.
Precisely. As Mr. Kumaga explained, it is not easy to grasp the actual lake current by field observation. Therefore, under a controlled experimental condition, we are trying to measure the fine structure of the current. Now, let's show you the actual experimental scene in the laboratory.
Thank you. This is the experimental unit, isn't it? This is larger than I expected. Does this reflect the exact topology of the lake?
No, it doesn't. We emphasize the depth over the length.
The horizontal scale is 1 over 30,000, while the vertical scale 1 over 300.
That means that the lake model is stretched to the depthward direction. That's why it doesn't look like a sheet of paper. Can you demonstrate how the model rotates?
Yes, why don't you press the start button? Would you explain about this experiment? Let's start with the apparatus. The entire model is mounted on the rotating turntable and rotates at a given speed. The rotation speed can be set anywhere you like. In this experiment, we will see what currents will be generated by heating water. Water is fed to this level and is warmed by the heater in the water. Temperature can be controlled by changing the voltage of the heater. How do you measure the current? When we look from outside, we can't see how water moves. It's because the model is rotating. As when you watch the movement of water from high above the surface of Lake Biwa, a camera is set over the rotating model to observe this movement. Fine aluminum powder is spread on the water surface to reflect light that clearly shows the current movement. The movement of the powder is continuously recorded by the camera. This is an overview of the experiment. The water in the model looks almost at rest after a long time of pre-rotation. The initial current is formed along the shore of the lake. Let's watch the scenes every 10 minutes. A counterclockwise gyre becomes apparent in the center of the lake. The gyre goes on wandering slightly, but the center is almost the same. I think we can correspond the rotation speed and the heat intensity to the actual Earth rotation and heat inflow, respectively. Here we have a table which compares and contrasts the characteristics of the model and the prototype of the northernmost gyre in Lake Biwa. In the rotating condition, there are two important characteristic lengths.
The first one is the Rossby number, which is determined by the current speed, the rotation ratio, and the lake's horizontal scale. The second one is the Ekman number, which is determined by the viscosity, the rotation ratio, and the depth scale of the lake.
These are the two parameters shown in this table, aren't they?
That's right. In order to obtain the experimental result which simulates the actual lake phenomena, the two parameters of the model must be consistent with those of the lake. The rotating speed and the degree of heating are controlled so that the value of these parameters are in accordance with each other. As you see, the experiment should be conducted satisfying certain conditions.
Then we have to convert the result of the experiment into the prototype situation.
The horizontal scale of the model to Lake Biwa is 1 over 30,000 and the time scale is 1 over 1,500. We must take these conditions into account when calculating. The velocity of 15 cm per second in Lake Biwa corresponds to the velocity of 1 cm per second in the model.
I see. Your explanation helps us understand why gyres are produced as a result of the Earth's rotation. Would a different kind of current be generated if we didn't have the rotation in the experimentation?
This is another experiment with the same condition except that the model doesn't rotate. No gyre is formed.
I still have a basic question. This model is rotating at the center of the lake itself. But I understand that the Earth is rotating on the axis through the north and south poles. How does the rotation of the lake model correspond to that of the actual lake?
It is not easy to explain it briefly, but I'll try to explain simply using this board. Suppose that this circle is the Earth. The Earth completes a full rotation counterclockwise once every 24 hours. Anything which is moving on the Earth, such as a water current, is influenced by the Coriolis force.
It is an apparent force, isn't it?
That's right. Now, vector F is the angular speed of the Earth's rotation. The vector V is the water speed moving on the Earth. Thus, we can show the Coriolis force by F times V. Let's talk about Lake Biwa. This is the Earth axis, and this is the vector F. We divide it in a horizontal component and a vertical component. In the same manner, we divide the vector V into two components. Then we can have three terms to describe the forces at work. In the gyres in this problem, the vertical current is negligible in comparison with the horizontal current. So, I love the third term, which represents the small force out. The second term is not small, but it's not important. It represents the vertical force of the current, but it's negated because the current moves horizontally. Finally, we can only take this F and this V into consideration. That's why it is okay to consider that this model of Lake Biwa can be turned horizontally around its center.
Did you understand the current generating mechanism? It consists of the combination effect of the heating and the Earth's rotation.
Yes, water coloring and aluminum flakes were very helpful to get an image of the actual lake current. Such a method is possible only under laboratory conditions. We still have questions about how the whole dynamics of the lake current can be expressed in this kind of small model. For example, we have not discussed much about the vertical mixing of the lake water. For the future of Lake Biwa, this kind of topic will be one of the most important factors. We expect to make progress in this field of study. Thank you very much.